In the previous video we had written a simple Java program. So in this video I will try to explain that Java program. Okay, so in that video I had just started out with Java programming. I didn't explain what all stuff meant. Okay, so in this video we'll see, or we'll take an overview of things in this. So to begin with, here we have an import statement. Okay, so an import statement allows us to import a package in Java. So what is exactly a package? So package is like you have a certain set of Java class files. Okay, so there are two types of files in Java. One is the .java file and another is the .class file. So this type of files are stored in your system. So a collection of class files is provided intrinsically by Java. Okay, so these are default packages like IO, util. Okay, so just remember these few packages that we'll be using. Okay, most probably we'll be using a lot of IO packages. IO stands for input and output. Whatever operations we are doing, or taking input from the user, displaying it on the console, or whatever stuff we are doing is done through these two things. Okay, so for that purpose we use IO, and the star denotes that I have taken all packages. But do I need all these things, all classes, sorry, not packages, all classes? But at this point I do not need all the classes. Okay, so what it does is it's doing some kind of redundant work for me, and it's taking all the classes inside this. So it is importing whatever is not even necessary. So whenever I run my program, so it will put some strain on the virtual machine. So here the concept of virtual machine comes up. So previously, if you have known about C or C++, or even if you're not aware of the workflow of how things work inside those languages, then the thing is C or C++ or those kind of low level languages are compiled languages. Okay, and Java is a compiled and interpreted language. By compiled and interpreted, I mean that Java is first compiled into a class file, or you can say a bytecode. So that bytecode is actually interpreted line by line by the JVM, or the Java virtual machine. Okay, so essentially in traditional systems, okay, traditional C/C++ compilation methodology, what happens is compile, link, and then execute. Okay, so the problem with these steps is whenever you compile and generate an object file, which is then translated into a executable by the linker. Okay, so the problem with this traditional execution was that it was not platform independent, it was dependent on the platform. So what this means is whatever code you have written on Windows will not directly compile on Linux or Mac, or likewise, or any other operating system like Solaris and stuff. So this was a major problem with languages like C or C++. So but when we talk about platform compatibility in even those languages, the problems in the early days were even for small libraries as well. Even for small IO libraries also there were problems. Now we don't have that much of a big problem because there are cross-platform C++ libraries as well. Like if you have known or read about Qt, so that's a GUI library that is available across all the platforms. Like it is available on Windows, Linux, and Mac. Slightly tweaking is to be done to make it work, but at this point that is not a big problem. Okay, but if you think of traditional language of OS specific functions, like for Windows you have something called as Win32 API or something of that sort, so that is specific only for those platforms, so that cannot be replicated on multiple platforms. So what has happened is the look and feel or the performance or all these factors, even if you are able to write some portable code in languages like C or C++, the performance definitely varies. Okay, so that is one major implication which led to the development of Java. So now for Java compilation process, or you can say compilation and interpretation process. So here what happens is, first you compile, and that is converted into bytecode, to bytecode. So here the compiler output which the linker takes is actually an obj file, that is an object file, sorry, and the linker then converts it into exe, that is the executable. Here on a Linux platform it will be a .bin file. Okay, it depends on whatever platform you are using. If you are on Mac it will be a DMG and stuff, so that is not relevant at this point. Here whenever you convert, it will convert into bytecode which will be read by the JVM. Okay, that is the Java virtual machine. So what JVM does is it provides a standard, you can say, interface to the programmers. So whatever you are writing in Java, it is same across the different platforms. The only difference is the connection between, or you can say the bond between JVM and the local machine. So this is your JVM and your local machine. So if your local machine has like Windows, so it will have a different type of JVM. If your local machine has Mac or Linux, so it will have a different type of JVM. So essentially the difference is between the JVMs. Okay, the bytecode is same across all the platforms. That is why the syntax as well of Java is same across all the platforms. So that makes Java platform independent. So whatever code you are writing on Windows should work on Linux, and it should work on Mac as well. But again there are exceptions for this rule as well in the modern terminology, if you think of things, because many libraries are now designed in certain way, like the modern libraries for reading comports and stuff. So there's some libraries are a mixture of native features, so there are like Java native interface and things are available, so those things can change how Java can function. Okay, so that is also to be considered when you say that Java is platform independent. Platform independent in the sense that if it does not use any native features, okay, then it is platform independent. Okay, so if it uses some native features where factors like the endianness of the machine or anything likewise is considered, then it might not work on one machine or the other. Okay, so that are the implications of this thing. And the advantage that the traditional languages like C++ offer is that they can go way too deep in the machine, or they can directly communicate with the machine. So that is one advantage that this traditional languages have. They can be used to write the operating systems as well. Okay, so all the low level stuff, the drivers, the kernel, and all those things are usually written in C or C++. Okay, so C++ is actually for the upper layer. For the lower layers like bootloaders and you can say the kernels and stuff is usually C only. Okay, the binding part which is added afterwards is usually C++. Most of the part is C or assembly. And newer languages like Rust are also being considered an alternative for C. Okay, so that also might develop one day. Okay, but for now C is only the language that is predominantly used for all the systems programming stuff. Okay, and Java at this point cannot do all those things. So Java, essentially if you're learning Java, then you are learning to write business applications. Okay, so the focus of Java is on business applications. So in business applications also there are different types of applications. Likewise the standard edition offers like desktop application development, so that is for desktop apps and stuff. And there is something called as enterprise edition. So the enterprise edition offers tools that are used to write smart web applications. So by web applications it can mean anything, right from a website to a web service. Okay, So those are different parts. And another branch of Java that used to exist, okay, before Android and iOS became a commonplace, was Java ME, or the micro edition. So that was one thing that existed in the past, which was a part of the older mobiles. Okay, so you could write applications in Java that were targeted towards the uh, older phones, you can say much older phones. So that was one part that didn't work out. Okay, now everything is replaced by Android and iOS. Okay, so those, both the languages, out of which one, Android, is something that can be programmed in Java as well. Okay, so your knowledge of Java can be used to write programs in Android as well. Okay, so this was it about the compilation process. And now back to the program. Okay, so I went a bit too far. Okay, anyway, so here, the test first class. So as I had mentioned in the previous video, whenever you are writing a Java program, take caution that your class name should match with the file name. Okay, only when you are using the main statement. Okay, so remember that thing. If you are writing a main statement in this thing, then make sure your class name matches with the file name, or else you will have problems when you are building jars or any type of packages after that. Okay, so I'd already discussed those things. So now the next line, public static void main. So here, public, static, and void main. So, and these are string arguments. Okay, so these are command line arguments. So whatever arguments you might give to your program when you're running your program in command line, like if you want to add two numbers, and you can give those two numbers in the command line as well. So if you can write, you can also write dash first space 12 plus 8, sorry, 12 space 8, and that will be considered as command line argument. So likewise, if you're writing, let me comment it out, sorry. So if you're writing like this, you can write Java dash first 12 and 8. So this should return you a sum of 12 plus 8. So that logic you have to write inside the program. So this is how command line arguments are given. For that purpose, this args exists. So this is an array of strings. Okay, so this is a string, so you need to convert to whatever data you are expecting. So here I am doing numerical operations. So what I need to do is, I need to typecast this value, or you can say convert this value from string to an integer, or if I'm doing some floating point operations, then I have to go to the floating point route. Okay, so that could be the case. So this is how it's done. And now once this is done, so in this line, the public and static are the keywords that are used to actually identify by the JVM. So once it gets the main statement, so this function needs to be static, because a static function is instantiated when the program goes live first. Okay, so essentially when the class file is loaded inside the JVM, okay, so it will search for a static function first, because static functions do not require any class based initializations. Okay, if you are declaring any non-static function, okay, remember that non-static functions will not be instantiated without a class name. Okay, so what you need to do in case of a non-static function is, like, you need to first create an instance of test first, and then call these functions whatever it will be. And secondly, the name that the JVM searches is main. Okay, so if you write something else in this case, that will not work here. Okay, so that are the two things that you should remember. The function should also be public. If you forget this parameter as well, it will not work. Okay, so, and one more thing, there are some implementations of older JVMs. Okay, those are privately forked and stuff. Okay, in those places you are allowed to change this thing, okay, you can remove this thing and you can use protected as well. Okay, in the older JVMs, in the newer versions you don't have this facility. Okay, so those are like written based on OpenJDK and stuff. Okay, so those are completely different. Okay, so if you are trying out for a commercial thing, that is, now JDK has basically two licenses. One is the open license and the other is the standard license provided by Oracle. So the standard way is to use this thing as public static void main. Okay, so after that I have written buffered reader br is equals to new buffered reader in the bracket new input stream reader system.in. Okay, so here, as I have previously mentioned, see here java.io.star. So these functions which are written here are the part of this thing. So let me show you. If I comment this out, you will get errors for this thing. Okay, sorry. uh, cd java tools. So let's compile this thing again. Java c test first dot java. Okay, it's taking too long to compile this thing. Okay, see here, it cannot find symbol buffer reader. Okay, so here I can write it this way as well, java.io dot buffer reader. Okay, rather than writing io.star, I'm writing individual class names. Okay, just save it once, try again. Okay, you will have one less error. See here, I had 4 errors previously and now I have 2 errors. One is for input stream reader and one is for IO exception. Okay, so here what I could do is input java.io dot input stream reader. Okay, input stream reader. Here, and finally for IO exception, so I'm using only these 3 for this thing. Other than that I was not using anything, but still I had written star. So that is one programming practice that you need to get rid of whenever you get to writing larger number of codes. Okay, so if you use a wildcard expression like star, that will include all the redundant unused classes into your program, so that will actually bloat your apks or jars or whatever you're taking here. So avoid those things. Okay, in modern IDEs, like if you're using Eclipse or NetBeans or IntelliJ or anything likewise, they will tell you these are redundant what you can say imports, and you can remove those things. Okay, so listen to the IDE when you get to the point where you can use the IDE. Okay, so I'm saving this thing and let's see. Okay, that's working. And again, test first, enter your name, test 001. So it's working fine as it was previously. Okay, so here what I've written is buffer reader. So buffer reader, see here, buffer reader is part of the IO package. Okay, so there are standard packages that are provided by Java, default packages you can say. You can create your own custom packages as well, that we'll learn in some other video. That's probably way too far from this point. Okay, uh, then there's thing like new buffer reader is new input stream reader system.in. So buffer reader basically allows us to read the data in form of buffer. Okay, so that's exactly what it does. It's a buffer reader. So whenever, at this point, we are taking input from an asynchronous source only, it's a keyboard. So whenever there are asynchronous sources or even synchronous sources, such kind of buffer readers usually help. Okay, so when we don't know when data will be available at this point, so there you can use such things. Okay, another alternative that was previously available was a data input stream. Okay, you could use. So whenever you don't know when the data will be arriving, you have to use some kind of buffered reader. Okay, so if you're connecting to any kind of serial devices or anything likewise, okay, if you're good in electronic stuff, then you might know there's something called communication baud rate. So if your baud rate is low for the sender, okay, and here your communication device is a bit faster, then in those cases you have to use the buffer reader, or when you don't know how much of a data is coming from any point, and in such cases buffer reader is used. And here, new input stream reader, the input stream reader is the main class here, which is embedded inside the buffer reader. So input stream reader reads data, but this provides the buffer for this thing. So this is kind of encapsulation layer to read it in a buffered way. Okay, so here system.in, so here we have written system.out. Here we are taking input from the user, so system.in for input. Okay, so this output and input, remember this thing, are from the perspective of the computer. Whatever you type is an input for the computer. Whatever computer sends you, it is an output for the computer. Okay, so remember from that perspective. And here I have declared a variable called name, okay, of the data type string. Here important case that to be noted is the data type. So string is the data type here, remember. If you are using some other data type, for string you do not need any type of typecasting for this thing. But if you are using something like integer, then let's see what happens. So name cannot be an integer, but for the sake of testing out things, we'll see what happens here. See here, string cannot be converted to the integer. Okay, so here buffer reader, or you can say the buffer reader dot readline function, returns a string. So if you are using an integer, so what you need to do is integer dot parse int. Okay, parse int will allow you to parse that thing. It will convert it into an integer kind of thing. Okay, so if you are using a float variable, that is the decimal number based variable, or the double, so for that functions you have to write float dot parse float and double dot parse double respectively. Okay, so that's something that you need to remember. Okay, and again, and see, this time it compiled successfully. So now test first.java. So here it is important that I give only numerical values. See here, if I write numerical values, works perfectly. But if I'm writing something like alphanumeric character, or you can say alphabet, sorry, see what happens. See, it will give me a number format exception here. If I'm using, if I'm putting an input of other data type, then I will get an exception here. So whenever the input does not match, okay, with the function, then it will generate a number format exception. Okay, so that is something that you will need to remember. So after this thing, there's something called as IO exception. Okay, so IO exception occurs when the IO fails. Okay, in case this system.in does not exist, like now you are reading from the keyboard. Okay, but if you are reading from a file, okay, here assume you are reading from a file and that file does not exist, so that will be a case for IO exception. Or if you are reading from a live network stream and the stream breaks off or any type of interruption occurs, so in such cases also you will get an IO exception. Okay, so for those purposes, Java has inbuilt exception handling capability, which was not present in early days in programming languages like C++. Now it is a norm, and so C++ also has that capability at this point. Okay, but back in the day, C++ did not have exception handling, so Java had that feature back in the day, and it has now as well. So here, after catching this thing, if you have any IO exception, you will get that exception here, and it will tell you error occurred and get message. So now if you want to test this IO exception feature, sorry, not IO exception but exception feature, so then we had got a number format exception, right? So we'll do that as well here, number format exception. So let's do that again, number format exception. Yeah, Java C. And here if I type that thing again, error occurred for input string whatever we have written. So this will give you a right message. So why actually this method exists of exception handling? So what essentially it does is it handles all the errors that might have occurred during the execution of the program. So this makes it easier to continue the program even if there are some minor errors or any type of catastrophic events occur during the execution. So this allows, or this provides a better user experience. Okay, so that is the case here. So this was it. This was a simple, you can say, explanation of the first program that we have written. Okay, in the upcoming video, which will not be as long as this one, I guess, we'll go through different parts of programming languages. Okay, hopefully you guys will join me there. Thank you.